Hey everyone, thanks again for joining for today's office hours session on getting better reliability on AWS with Gremlin's latest release. Some quick notes before we get started. This is an interactive webinar. I want to hear from you as much as you want to hear from me. So please feel free to enter any questions you have into the chat or the Q&A panel, and we'll get to them after the webinar is over. This webinar will be recorded, and the recording will be made available. So if you logged in late or missed a certain part of it that you want to rewatch, that will be available to you. If this is your first time at office hours, welcome. This is our monthly series where we cover features in Gremlin and best practices and cool things that you can do with the product. If you're interested in learning more or you want to see future sessions or past sessions, you can head to gremlin.com/office hours and get a link to those there. So today we're going to be focusing on four big features. First is easier onboarding of AWS services. We're going to look at intelligent health checks that are specific to AWS. We're going to look at AWS-specific detected risks that we've added. And also we're going to look at a brand new test suite that we created called the Well-Architected Cloud Test Suite. After we go through a quick presentation, I'll show a demo of how all of this works in practice, and then we'll end it with Q&A. And again, just as a reminder, because I like to repeat this over and over again, I'm here to answer your questions. So if you have any that come up during the webinar or any that you came with, drop them in the chat. I'll look through them and I'll address them during the Q&A session. So I'd like to start each of these with a set of goals. So for this session, we're going to do a few things. First is we're going to onboard an AWS service into Gremlin. We have an application running on EC2. We want to get that into Gremlin so we can start running reliability tests and get a reliability score on it. We're going to configure Gremlin to run AWS-specific tests, or at least I'll show you how you can do that. And then we're going to detect configuration issues with our AWS service before running any tests. So these are automatically detected risks that Gremlin picks up on its own. And if you have any goals, any things that you're trying to accomplish, or if you're just using AWS and you're pulling your hair out and you need help in some way, form, that's still a goal. Let us know how we can help. And hopefully this webinar will give you some guidance and a good direction to go with that. So why did we start with this? Onboarding and service creation is a common hurdle that our customers run into. A lot of our customers are running these massive environments with hundreds, thousands of hosts, if not more. And when they start using Gremlin, a big question is, how do you onboard all of those different hosts into Gremlin? So our approach with AWS was to create a solution that uses elastic load balancers, or ELBs. Short story is, if you have a service running on EC2 or EKS, and you have an ELB pointing at it, whether it's an application load balancer or network load balancer, Gremlin will automatically identify it. All you need to do is select it in the list and confirm. The way this works under the hood is that we're looking at which host the ELB is pointing to. Since each of your hosts has the Gremlin agent running on it, we already know certain details about it, like its instance type, its IP address, its internal IP address, things like that. And we can very easily associate an ELB to that. So for example, when you create a service based on an ELB and you want to run a reliability test, that's how Gremlin knows how to distribute the reliability test when you click run. So you don't have to add every ELB in your account as a service. You can select which ones you want to add or remove. And if you have a service in Gremlin that's already on AWS and you've added an ELB to it afterwards, you can also edit existing services and add the ELB after the fact. If you're worried about permissions, the way we design this is that we only get very limited read-only access to CloudWatch, Route 53, and ELB. The reason we include CloudWatch is so we can create health checks using those ELBs, which I'll get into later. And we understand security is a big concern for a lot of companies. So if you want to see exactly what permissions we're requesting, we post the full policy request in the web app as you're setting up onboarding, and also in our docs. So that way you can read through it, audit it, maybe send it to your security team for review, whatever you need to do. We try to be as transparent as possible. And if you can't or don't want to use IAM or their authentication management, we also support old school service accounts. So you can authenticate Gremlin that way as well. Again, we're not modifying your AWS environment. We're not making any changes. We're not looking at things that we shouldn't. We're just trying to understand how the ELB maps to your backend host so that we can get those health checks created and those experiments running. So before we even get to like health checks and running reliability tests and all that fun stuff, the very first thing that Gremlin does once you add a ELB as a service is detect risks. So if you're not familiar with detected risks, these are high priority reliability risks that Gremlin automatically looks for in any service that you add to it. You use configuration data that's already available and doesn't require any additional effort or button presses from you. So we started this out by releasing 10 Kubernetes specific risks. And with this release, we're adding three more specific to AWS. These are the ones that show as mitigated in the screenshot. First one is load balancer AZ redundancy. This checks to make sure that your ELB is mapped to at least 2 availability zones. So in other words, it checks that both your ELB and your service are redundant and have failover systems in place. Next is cross-zone load balancing. This is an AWS feature that's designed to evenly distribute traffic across all instances in your AZs. By default, load balancers can skew traffic distribution if you have an uneven number of instances in different AZs. This is a simple true-false attribute that you can enable in AWS. Doesn't require any additional effort. So all you need to do is go in and basically toggle the checkbox and you're good to go. The last one is load balancer deletion protection. This is another basic on-off flag that determines whether you can delete a load balancer or not. When enabled, you get an error message if you try to delete the load balancer. Doesn't matter whether you use the AWS console, API, or command line tool, they'll all return an error if you try to delete it while this is enabled. And the reason why we focus on this is that this is designed to prevent accidental deletions, especially if you're using an infrastructure automation tool where deletion might be pushed accidentally. Let's say you have Terraform and you push a Terraform update, but by accident, somebody might have removed the load balancer definition. We want to prevent things like that from impacting your production environment, so that's why we check for it. The only exception is for classic load balancers. Those just don't support deletion protection at all, so they're always considered at risk. Oops. And so with that in mind, let's move on to health checks. This is another big stumbling block that we've seen new users run into. And if you haven't added health checks, or rather, if you haven't used health checks before, these are simply periodic checks that Gremlin performs on your services during testing. Typically, you connect these to an alarm or metric in your observability tool. The most basic example is just sending an HTTP request to your service's endpoint, like if you're running a website or something, or a web service, just to check that it's available and responsive. But let's say you don't have a signal set up. Let's say maybe you don't have observability in place, or you're in the middle of building it out, or you're just not sure what metrics to track. A lot of teams we talk to have this problem. So to help resolve this, we created what we call intelligent health checks. And these are health checks that Gremlin can automatically configure for you and run on your AWS services. The way it works is it finds out which CloudWatch metrics are relevant to the service based on your ELB. Again, that's why we request those CloudWatch that access. And then monitors those metrics to understand your service's baseline performance. And when you run a test, it looks for anomalies. And if it receives an anomaly or a value that's way outside of the norm, it will identify this as an issue, mark the test as a failure, and then immediately stop it to get your service back to normal. The really nice thing about this is that you don't have to do any configuration beyond what's shown in the screenshot. You just click that checkbox and you're good to go. You can also combine these with other health checks if you want extra coverage. So let's say you have another metric that's important to you that you receive from CloudWatch or Datadog or Dynatrace or whatever it might be. You can use as many health checks in tandem as you'd like in addition to the intelligent ones, up to, I believe, 20. But anyways, you have that option. And as a little fun aside, if you've ever read Google's SRE guide, you'll notice that these probably look a little familiar. And that's because we actually base these on the 4 golden signals, which is latency, error rate, throughput, and saturation. We focused on the first three because they had the biggest impact on user experience. Though if saturation is important to you, you can always add a regular health check to cover that for you as well. So let's say you've gone through, you've added your services, you've set up your intelligent health checks, you've got your detected risks, you're ready to go. You can use what we call our well-architected test suite to sort of boost your coverage a bit. So if you're not familiar with test suites, they're exactly what the name implies. They're just a collection of reliability tests, specifically Gremlin scenarios that you can run on your services. They also include detected risks. So the main thing about test suite is that it determines how the reliability score gets calculated. So like you see in the screenshot, this one is based evenly off of these 3 different test categories, and then also the detected risks category as well. When we first launched test suites, we included a default Gremlin recommended test suite, which I'll show you in the demo. Now we've added this well-architected test suite that includes the Gremlin recommended suite, but also adds some new cloud-specific tests and also the AWS detected risks. One of the new tests is a disk I/O test, which is useful for testing disk quotas on AWS. And then we have a classic DNS redundancy test. So just making sure that your services have redundant DNS services to fall back to. Just want to mention real quick that nothing in this test suite is AWS specific. We expect most customers to run these tests on AWS just because that's where most of our customers are running their services. But you could take this and run this anywhere, right? If you're on Google Cloud, if you're on Azure, even if you're on-prem, there's still very useful tests in this. The only thing that's AWS specific are the detected risks, but Gremlin will just remove those from the calculated score since it knows that they're not relevant for that specific service. All right, that was a lot to cover, but now we get to see it all in action. So I'll jump over to the demo. Again, I do see we have a question come through actually, but want to remind everyone that if you do have questions, you can enter them into the chat or the Q&A panel. So the question is, how can we monitor new Kubernetes pods which spin up once we attack resources on the existing ones? So great question. By default, when you run a reliability test, Gremlin will just automatically know that those new pods are spun up and it will distribute the test to those as well. They're just automatically included. If you're running, let's say, a custom experiment or custom scenario, you can actually choose when you're selecting the pods or deployment or whatever it is to target, whether or not to include new resources in the attack. But by default, they're just included automatically. It's a great question, though. All right, so with that, I'll just switch over to Gremlin. And you'll excuse me for looking away from the camera. It's just my setup here. My laptop's all the way on the other side of the desk. So I'll be looking back and forth a bit. All right, so when you first log into Gremlin, this will look very familiar, this getting started screen. What might look new to you is if you scroll down, you'll see this define your services section, and also the option to select AWS or something else. Naturally, we're going to want to select AWS. If you haven't yet authenticated with AWS, it will ask you to enter your AWS account ID. It will give you that policy that you can put into AWS, IAM, or service accounts to be able to authenticate Gremlin and give it access. But once you do, you'll see this section will ask you what account ID do you want to use. If you have multiple, you can click on this and select which one you want. This is great if you're using different accounts for, let's say, your production services or your testing services. You can have both of them in here and be able to just pick and choose what service you want to add from which environment. I only have one, so I'm just going to select that one, and then I'm going to click next. And now what Gremlin does is it goes out, it sees what ELBs I have in that account, and it lists them here. It also lists some things like its DNS name, its region. If I had any additional tags, it would list them here too. This table looks a little funky because I haven't really zoomed in for this webinar, but typically we have the full name shown. So the one I want to add is called Office Hours Web Application, or Web ELB, which is right here. So I'm going to check that, and then I'm going to click Create One Service. And right away, Gremlin takes that, it creates a service, and then it lists, again, the different ELBs we have available in case we want to, or rather, it lists the services that we created from ELBs that we have in our AWS account. So this is the one that we just created. This is one I created earlier. So I'll click into it. Some really cool stuff that we see right off the bat. Gremlin detects a whole bunch of metadata from different AWS services. Again, it's tying the ELB to the EC2 instance that I have running in the background. So we know it's a T2 micro. We know that it's running in US East 2. We know its public IP address. Please don't hack me. We know it's AZ ID, and we also know its public DNS name. So just a bunch of metadata that we use to make it easier to know what service this is associated with, and also being able to like filter and sort it as we're going through the service list. So if you scroll down, you'll see we already have a reliability score, and we also have detected risks. And so when I click into here, again, these are those AWS detected risks that are automatically detected for me. I see that I don't have deletion protection enabled, but I do have AZ redundancy and cross-load load balancing enabled, so that's cool. Gremlin also detected, this isn't an AWS specific one, it's one that we include automatically. It just noticed that my EC2 instance doesn't have availability zone redundancy. It's just one instance running in one zone. So naturally, it's going to fail this. But again, this just shows that if you have detected risks that are relevant for a service or not relevant for them, Gremlin automatically knows whether or not to include them. So you don't have to do anything with that. So the next thing I'll show you before we start running tests is the intelligent health checks. You'll note here it says intelligent health checks been added to your service. That's just done automatically because it knows that this is a AWS service. But if you want to confirm or double check, just go into settings, then click health checks, and you see that checkbox right there that shows that these health checks are enabled. This is what I was referring to earlier, the mapped ELB. This is where you can define what ELB the service maps to. So since, of course, we created this one from the ELB, it's already mapped. But if you had a service that wasn't mapped, you can just go in here and click edit, and it will be able to select your ELB from there. And like I mentioned earlier, you are able to add additional health checks. So let's say I wanted to run a health check that just pings the front end for the service. I would just go into health checks, find one that I already created, click on it, and then click add, and it would appear right there. So that's just another way of adding additional coverage if you have metrics that you're concerned about for this service. So we had another question come in that said, can you talk or show us how to install the Gremlin agent on an AWS VPC? So the Gremlin agent doesn't install onto a VPC directly. You install it onto the hosts that are on that VPC, if that makes sense. So if you have an EC2 host, or rather in this case, I have an EC2 host that's running on a VPC. So I installed the Gremlin agent on there. It reported back to our control plane, our backend servers, and that's how it detected the agent. If you have, let's say, a private VPC with no outbound connection to the public internet, so it can't make a direct connection to our servers, we do offer a proxy service that you can use. So that way, you don't have to expose that instance to the public internet. But that's available in our documentation. So if you'd like answers on that, I can grab that link for you, or you can just go to docs.gremlin.com and you should be able to find it there. All right, so we covered a lot of the settings, a lot of the sort of background context. Let's actually run an experiment. So I'm going to go back to the services page, and let's find, I don't know, let's say the CPU experiment. We'll click run. We'll confirm that the service will be impacted. And as the test is running, you'll start to see the typical, test running screen that you've probably seen 1,000 times before. But you also notice that it pulled in our intelligent health checks. And in a second, once it queries those health checks, we should see them appear on this chart here. So that would show us a historical record of what Gremlin has seen for this service, whether or not our health checks are healthy or not. And so we can see the exact moment when a health check triggered the reliability test to stop, or if it was successful, we should see a straight line of successful health checks. And it seems to be taking a little bit to actually run those health checks. So hopefully it won't take too long. So you'll be able to see what that looks like. There we go. So yeah, right now everything's healthy, everything's good. If you scroll down, we'll see that the test is actually running. We're starting with this CPU experiment that uses 50%. So we can already see that the instance is hitting that CPU that we're targeting, and everything is still looking good. So this is just another way of confirming that everything is set up correctly and that your health checks and your service test are running okay. And again, if we had another health check, like a regular health check, you'd see that show up here as well. So we'll just let that test run, and maybe it'll finish by the time this webinar is over so we can see what it looks like afterwards. In the meantime, the last thing I want to show you is that well-architected test suite. So if you go over here and click into test suites, we'll be able to see all the different suites that we've created. The Gremlin recommended is our default one that everybody gets access to as soon as you create your Gremlin account or your Gremlin company. But the well-architected cloud is the one that we recently created. So if we click into that, we'll be able to see how this test suite is built up. We'll see how the score is calculated. We'll be able to see which teams have used it. We'll see what tests make it up. So here's that new DNS redundancy test and also that new disk.io scalability test that I mentioned earlier. And we can also see the risks that are included. Again, these are the detected risks. So by default, all of our detected risks are included in the score. But let's say that we know that we don't have any Kubernetes services running on AWS. We can go into here, select all the Kubernetes specific risks, and then move them over to this table. Since this is a default test suite that's included in Gremlin, I'm not able to edit this one, which is why dragging and dropping and there are no buttons or anything like that. But if you want to edit this and customize it yourself, you can just scroll up, click clone. That'll create an exact replica of this one that's specific to your Gremlin organization. And that way you can tweak it. You can add, remove risks. You can add or remove tests. If you have a custom test that's made from like a Gremlin scenario that you want to add, you can add it here as well. It's very customizable, very flexible. Again, you will need to clone it first. And then once you have your test suite built up and you're ready to start using it, just assign it to a Gremlin team. In this case, my team is product testing. So all I need to do is click it, click add, then go down here and click save. And what that will do is all of the reliability tests that I have set up to run on my services will be replaced with the tests in this test suite. So in other words, right now I'm using the Gremlin recommended test suite, which has its own set of tests. If I were to add my team to the well-architected cloud test suite, I'd start using the tests that are defined in the well-architected cloud test suite. And for the ones that I've already ran from the Gremlin recommended test, Gremlin will move those aside, but it will also save the scores and save the results. So if I want to change back to that one at a later time, it'll automatically recover those scores. I don't actually lose everything. Depending on how long you've waited, the scores may show up as expired, but you won't lose that test history. And the same goes for detected risks as well. So that was a really quick, really sort of fast-paced walkthrough of our new AWS features. I do see we have a couple questions coming in, but real quickly, I would just like to wrap up with one more slide. If you want a more in-depth walkthrough of these new features, including a video, we have a blog that we wrote that talks about everything that I mentioned in this demo with links to additional resources like getting started videos, like our documentation, and also list out the new features that are added. If you're feeling adventurous, we have a quick start guide in our docs that will walk you through this exact process from start to finish. You can go to gremlin.com/docs/AWS-quick start guide to be able to see that. We also have it in our navigation menu, so you can get to it from there. If you're brand new to Gremlin, don't have an account yet, that's totally fine. You can sign up for a free 30-day trial by going to gremlin.com/trial. And again, just as a reminder, we have these sessions monthly, and these sessions are for you guys. So we post all of our upcoming scheduled sessions and topics on the website at gremlin.com/office hours. They're all free, but all available for anyone to sign up to. This is also where we post recordings from previous sessions if you want to watch those. And we're also looking for feedback. So if you use anything about Gremlin or using Gremlin that you're interested in learning more about, or you want one of us to dive deeper into, you can always reach out to us either by messaging us at the end of this webinar or going to gremlin.com/contact and just let us know what you think or let us know what you'd like to see. We're always open to recommendations. So with that, I see we have a couple of questions in Q&A. So let's see, one is, should Gremlin agent be installed in every on-prem Red Hat VM for doing chaos engineering reliability tests, or can it be agentless? So at the moment, we do require that agent to be installed on a host in order for, or rather a VM for tests to run. We are offering a new feature called failure flags, which lets you run experiments within application code. but that's sort of a different approach, and right now isn't quite as feature rich as our agent-based testing. But what you can do is, if you have like an automatic deployment model for your VMs, you can add just some instructions to download the Gremlin agent and to authenticate it, so that way it's set up automatically. Gremlin will just automatically know, it will be able to identify each VM separately based off of its IP address and other metadata. So you don't have to worry about like conflicts or anything like that. But our recommendation is install it on every VM that you have. And so that way you have the option of orchestrating chaos experiments on them if you'd like to. So hope that answered your question. Another question is, my team is testing a large ecosystem, which is stored on private data center, half on VMs and half on Kubernetes. Where to start? That's a really good question. My recommendation would be to start with Kubernetes, just because there's so much more flexibility you can do with it. You can run experiments on containers directly. You can run experiments on deployments or daemon sets or stateful sets or whatever you might like. Just gives you a lot more flexibility. So we have a Gremlin Kubernetes agent that you can install using Helm, or just by using regular YAML files. And what that'll do is that'll deploy a Gremlin daemon set. That daemon set will be able to identify what the pods, deployments, and other Kubernetes resources you have running on your cluster. And so from there, you'll be able to select those resources. And I wish I could show you what that looks like in practice, but I don't think I have a Kubernetes service in this account. I'm just going to check really quickly. Oh, I do. Okay, perfect. So yeah, once you have that agent running, you'll see Kubernetes, this tab will be enabled, and it'll say, some number of pods available. You can choose your cluster, choose a namespace if you want to get specific. You can use label selectors or enter label selectors to decide what resources to target. But the method that I tend to use, just because I'm a little lazy, is go to exact. And now we'll be able to see everything within our Kubernetes cluster. So I have a few deployments and a few stateful sets. I can select one and just see immediately what it will look like if I actually run an experiment on this. You can fine tune the number of pods in the deployment that you want to target, or just specify an exact number. And for the person earlier who asked, will Kubernetes resources or will new pods get included in the experiment? That's what this button does. So if you come over here and you have this option to include new targets, just check that. So now if I get a new pod in this balance reader deployment spun up, it'll just automatically be included in the experiment. Here it's disabled by default, and in the reliability test or in the services section, it's enabled by default. So you just have to keep that in mind as you're going between them. But otherwise, just creating an experiment looks exactly the same. You go down to choose a Gremlin, you pick from the different types, and then you click run. So that's all similar. It really just changes the selection criteria up here. So that was a long-winded way of saying I recommend starting with Kubernetes, but also when you're ready to sort of expand your test, you can deploy those regular agents on your VM so that you can get those included here as well. I don't believe we have a very easy way of orchestrating tests across both Kubernetes and VMs. But what you can do is, if you want to run a test on your Kubernetes VMs or your Kubernetes instances, you can go to hosts and you'll be able to find them here too. So I think so this Gremlin lab worker is one of my Kubernetes hosts. So I can select it here and run an experiment through here as well. It's a little different because it's not fine-tuned to a pod or a deployment, but it'll get you there. So, great question. Let's see, are there any more questions coming through? Again, don't be shy. If you have any questions at all, you can feel free to ask them. It could be about Gremlin, about the AWS, about the integration, or just anything in general. In the meantime, I'll go back to that services page so you can see what that looks like. Actually, on that note, let's see if our test is finished. Okay, it's still running, but it's a little further along. And it hasn't failed yet, so that's a good sign. I honestly wasn't expecting much from this little T2 micro instance, but if it's able to handle 90% CPU usage or 75% CPU usage, then I think that's a pretty good sign. So I don't see anything in the Q&A panel. Don't see anything in chat. We'll give it just a couple more minutes in case anybody thinks of anything. Let's see. Oh, will you be sharing this webinar recording? Yep. Once the webinar is done and the recording's processed, we'll be sharing it out. So you'll get access to this once it's done. All right. Well, if that's all the questions we have, I think we can probably wrap up a little early. If you do think of a question after the webinar ends, you can always reach out to us at gremlin.com/contact, or I believe we have a form after this webinar that you can fill out. Also, that's a great way to let us know how we did, what you think we could do better, and any recommendations for future office hours sessions. Oh, well, I had another question come through really quickly. Can we include Gremlin test in CI/CD automatically? Yes, we can. The way that we typically recommend this is by using Gremlin has a REST API that you can use to perform any experiment that you saw in the web application automatically. So what we typically recommend is creating an API call to do something like initiate a reliability test or initiate an experiment. That way, so when you're in the middle or after you've deployed, let's say, update to your application, you could run that experiment. You can also check its progress or check its results. And that way you'll know, does this do a version of my service or whatever it might be, add any reliability regressions, or can we trust that it's reliable to push to production? It's a little complicated to try and explain over a webinar, but we do offer some tutorials if you go to our site that walk you through using CI/CD, I believe with Jenkins as an example. So the short answer is that yes, you can do this. The longer answer is that we recommend using our REST API to do that. All right. So again, thank you all for joining us. Hope this webinar was helpful and informative for you. If there's anything that you would like to reach out to us about, again, fill out that form or reach out to us at gremlin.com/contact. And hopefully we'll see you in a future session. So thanks again for joining us and take care.